In this class, we're going to take a look at quadratic expressions and quadratic functions. This class is just an introduction, kind of overview of this topic, and the ultimate destination of this topic is really quadratic equations. Once you've learnt to solve linear equations, that's like normal equations where you get a single value, like x equals 5 or something, then the next step up really is quadratic equations. Before we can get to quadratic equations, we need to consider what are quadratics, what are quadratic expressions, what are quadratic functions. So I'm just going to kind of lay that all out today in this class, and then there's nothing really to practice as such from what I'm going to show you today, but just kind of get this overview and then start to move your way towards quadratic equations. So first of all, what is a quadratic expression? Well, a quadratic expression in general terms is one that looks like this: ax squared plus bx plus c. So what makes that a quadratic versus something else? Well, the key really is the x squared term. So having that x squared term is mandatory. That is the requirement for it to be a quadratic expression. But also, if you've got an x squared term, then you do have a quadratic expression. But notice that it can't be any power higher than an x squared term. So for example, if you had an x squared term, but you also had an expression that contained an x cubed term, then that's no longer a quadratic expression. And in fact, we always go by the highest power, so this one would actually be what's called a cubic expression. So we're dealing only with quadratic, so this is a general form of a quadratic. But all you really need is the x squared term. So you could have just simply x squared, like 1x squared, and that is an example of a quadratic. That is the most basic quadratic you get. If you then start adding numbers in here, that's still a quadratic. You could add in maybe like an x term, like 3x's or something, that's still a quadratic. You don't need to have a number term, you don't need to have an x term, but you could add in a number term, and that's a quadratic. So you're going to see all sorts of different formats. This is the most popular, probably, I guess, format, which is called a trinomial, where you've got 1, 2, 3 terms. So x squared term, x term, number term. But you're going to see a lot of quadratics which are written with the x squared term and then maybe just a number. You can see quadratics written with the x squared term and then just the x term. So there's a whole bunch of varieties. You might even see some that are written with a number in front of the x squared term and it's still a trinomial like that. You'll see every single one of these as you move through working with quadratic expressions. When you take a quadratic expression and turn it into a function just by writing f of x in front of it, then that's starting to move towards a different area. So ax squared plus bx plus c, where we're starting to think more about what can we do with these quadratic expressions, in particular thinking about the graph. So sometimes as well we'll write this as y equals ax squared. So this is taking basically a quadratic expression, which is the trinomial part, so this part here. This is the expression part, this is the expression part, and thinking about it as a function or thinking about it as the graph. So if we were to start plotting points using x and y's according to this little rule here, this formula here, then we could start to make a graph. We're not going to get into that today. That's somewhere you'll probably go fairly quickly if you're just starting out in this quadratic topic. You'll eventually see the graphs for these take on a very particular shape. They take on this kind of parabolic shape like that, and you'll probably spend quite a bit of time working with quadratic expressions and considering how the graphs of those look. But all I want you to really take away from this class today is the general form of a quadratic expression, ax squared plus bx plus c. The fact that you can then take a quadratic expression and turn it into a function, or think about the graph that's as a destination, that's where you're going in the future. The fact that you can get quadratic expressions in a whole bunch of different formats, so don't think it has to be this trinomial format. And where you're probably going to be going with this fairly soon is to take these quadratic expressions, maybe think about them in terms of the graph, and partly also related to the graph, think about them in terms of equations. So ax squared plus bx plus c, so quadratic expression equal to 0. Okay, so that's now turned that into a quadratic equation. You'll see connections between this and this because we can get here just by putting a 0 in the position of f of x or y, that's going to have some implications. So there's a whole bunch of different parts to this topic that pieces all of this together. So I'm just kind of like throwing all this stuff out there and it's all a bit disconnected. And if this is brand new to you, it will seem very disconnected at first, but you just want to slowly build up your skills. Quadratic expressions and quadratic equations are really important. They come up in a whole bunch of courses. They come up a lot in pre-calculus. They'll come up in your calculus course. They'll come up in a whole bunch of things, even at higher levels as well. So they're really the first step beyond working with just simple linear equations. When you start looking into these guys, there's a few quirks about how you solve these equations. There's quirks about how you conceptualize those equations. There's things that we can do with that over and above what you can do with a linear equation. A normal linear equation, there's not much you can do with it other than solve it, but these guys are a bit more sophisticated and there's more that we can kind of talk about quadratic equations. So that's just really an overview. Just take away those key points, just know what a quadratic expression is at this point and start to work your way towards quadratic equations.